All right, hello everyone. So first of all, I want to say thank you to ARC for the opportunity to present and speak here today. Like Preet mentioned, my name is Chad Sargant, and my core role at Dow is intellectual property protection lead for our hydrocarbons business. And so I've been with Dow for 15 years. I've held a variety of roles related to operating of facilities. I actually did a stint in environmental health and safety as a delivery leader there. And I also had a role in mega turnarounds, leading project integration and project controls. So my core role is what originally brought me into this effort. However, my passion for digitalization and my interest in AI has led to my core role growing. Again, earlier, like they mentioned, without pay. But it has grown into being the product owner for this app. And what the product owner does in Dow is work with the team to set the rollout strategy, train users, lead implementation of bug fixes and enhancements, track metrics, and more. Essentially acting as the liaison between the project team and our targeted end users in the facilities. So over the past 2 years, what we've been doing is applying AI in an industrial application to improve the performance of our furnaces and our ethylene crackers. So if you're not familiar with the cracking process, the furnace is essentially the piece of equipment that does the conversion from our feedstocks into our desired end product of ethylene, which is then sent to our partners and downstream facilities to be produced into our end products. So think like polyethylene, for example. Today I'm going to share our implementation approach, the lessons that we've learned, and the positive outcomes that we have achieved. But before I do that, I do want to give you a basic overview of the application, its capabilities, and its intent, so you can fully understand our journey. The focus of this presentation is not to go into excruciating detail on the application itself. I'm not a C3 AI salesperson or anything like that, but I want to focus on our approach and what we have learned. So C3 has a large solution portfolio, but the one that I'm going to be focusing in on right now is our reliability application, or their reliability application offering that we're implementing for this use case. So in a nutshell, we are leveraging the multivariate semi-supervised learning to detect and alert on elevated system risk in our furnaces. So in simple terms, what that really means is we've used machine learning to train on large historical data sets of stable operating periods, and we're monitoring our current operating data within the app itself. And then if our current operating data starts to deviate by a defined amount or for a duration of time, then the appropriate end users are alerted to a potential issue. So this is an all-in-one solution that allows us to monitor our current operating conditions and some key performance indicators for our facilities. It has a full alert management suite that allows us to monitor alerts from when they're triggered, track investigation, resolution, and keep a long-term history of the closure of those alerts. It also has a sensor health module that monitors all of the sensors and the data coming into the application to ensure that we're getting good data. It hasn't failed high, failed low, we're not missing data, or it's not stagnant for a period of time. It also has a full machine learning model operation suite that allows us to develop new models, train, retrain, and deploy those models into use. It also has some other features that I'm not so much focusing on here today, but there's data analysis that can be performed in the app as well. The ultimate objective is to proactively identify issues before they occur and take preventative actions to prevent unplanned maintenance spending, minimize lost production, and ultimately improve our run lengths to achieve more pounds and more profit. So far, we've deployed to 4 crackers in the US Gulf Coast. In terms of asset counts, that equates to 37 furnaces and give or take a few, 373 machine learning models in total. So how are we doing it? As a team, so we assembled a multidiscipline and cross-functional team that consists of our Dow Hydrocarbons Technology Center representatives. So these are our business and process SMEs that know the cracker process and can understand where this application can be best put to use. We also have a large contingent of IT representatives, so data scientists, solution experts, and people who are experienced in IT project management and change management, for deploying an app at this scale. C3 also has a project team that essentially consists of, they're smaller, but they consist of the same roles as their counterparts in DAO. And we have our DAO operations personnel, so our local operators and technologists and engineers that are ultimately our targeted end users for this application. So like any other project, each team member is responsible for their own specialties, but it takes a full team communication, a willingness to learn, and commitment to be successful. And this is no different than any of what we've been hearing and during other presentations throughout the conference here. Good example, I'm a chemical engineer by my training or education. I only know the basics about application development and deployment at this scale, but I do know how a facility in DAO operates and where this application can be best put to use. Similar, or conversely, IT folks, they may not know about what a cracking furnace does, but they can definitely move data around, get it to the spot that we need it, and do it in a secure fashion. So again, it takes a full team. One thing I want to focus on in terms of implementation is actually change management. So it's been very key, and I've heard this a number of times already here today, but it's a great application, but it's only as good as the people that use it and ensure that it works well for our intended use case. So I'll talk about our full gamut of challenges in a moment, but we are placing an emphasis on this change management piece, just to ensure that we can maximize adoption and incorporate it into day-to-day activities of the end users. So primarily this means delivering an end product that is free of bugs, issues, and we've really refined the alerting. So we deal with these issues at the project level so that the end user doesn't have to. And I know that sounds perfectly logical, but one thing that I've kind of learned in the space of AI and digitalization, it's not uncommon that a app or a solution is delivered to an end user with bugs and the intention to fix those in an upcoming update or release. We also have the ever-present requirement of deadlines. There's always a rollout schedule that we need to meet, and we need to get there, and it can result in an imperfect solution. So what we're really trying to focus on is keeping those issues to our team and away from the end users. And this isn't something we've done since the beginning. I'll use an example of the chart on the slide here. So that red line is the cumulative risk score that we have in a particular subsystem for one of our furnaces. And this is in the early days of our first deployment. Along the bottom there, you can see those little alert diamonds. Those correspond to alerts that were triggered to the individuals in the facility. And so for this particular example, we had 8 alerts in a 3-week time span. And so they were coming in because a feed composition was different to the furnace than we had trained on. That's something that we missed in the early training, is that this was a relatively infrequent operating period, or operating mode, and because we missed it, we were getting a lot of alerts in this subsystem as well as other subsystems in the application. And it very much eroded the buy-in in the early days, and it took a lot of time to rebuild that trust with the local work team. So just in summary, change management is definitely a key perspective, or a key element. So that's just one of the learnings that we've learned through the course of this implementation. I have a number more that I want to share, so let me just start from the beginning. So our first deployment, just like any other application, it was the most difficult. We had to fully adapt the base user interface that C3 offers and add things like our key performance indicator customizations. There was some DAO proprietary functionality that we wanted to include. We also needed to do simple things like aligning the graphics to our DAO furnaces. So we also had to translate our DAO naming convention. We do have a lot of variation in how we name our various tags within our furnaces from site to site. And so we wanted to adhere to a common naming convention so that down the road, deployment becomes much more efficient and we don't make mistakes when we're creating these machine learning models and deploying them. We also had to figure out how to securely get the data from our process control systems into a place where C3 can ingest it. We had to stand up a work process for developing the machine learning models, reviewing them for accuracy, and approving them for deployment. We had to set up a process to conduct user acceptance testing. Like I mentioned before, we also had some challenges with those issues of the early stages going live to the end user. So primarily with that excessive alerting and user interface bugs. And so that did lead to some adoption challenges. One thing that we found early on was that when we started this effort, AI was still a relatively unknown concept within Dow. And so there was a lot of training required in order to bring people up to speed with what we were trying to achieve and some of the how it was working in the background. So all of these areas had learnings that we had to incorporate into the second and future deployments, and we're starting to see those efforts pay off. They're getting easier as we go along. One thing that we did, we have the data flow pathways and that common naming conventions already established, but we have ways where we can automate some of the more tedious work. So we've started to look at how can we make these deployments much more efficient and quicker. We also moved to that centralized team to basically keep the end user out of the early stages. So we originally brought the end users in very early in our first deployment for a couple of reasons. One, we thought that they could help us get through some of the more difficult stages like model reviews because of their experience with the facility. And two, we thought it would help with that buy-in. If they're with it from the ground up as we developed the app, we thought that there would be much more buy-in. But like I mentioned, it didn't quite pan out as we anticipated. So what we've done is we've kind of taken a step back and implemented what we call a go live for our technology center, where it goes to our technology center SMEs before we deploy to our end users so that we can identify any issues that were not identified in user acceptance testing and get those ironed out before we actually deploy the application. The main challenge we experienced was moving from 1 to 2 facilities in the user interface itself. We needed to adapt it to our new data security framework. Like, we want to keep our data on a facility by facility basis. So we don't want individuals from one facility seeing data from another facility and vice versa. But we still need to maintain that holistic view for the global users and the Dow SMEs. And so that did lead to some delays while we were developing the user interface, and we needed to resolve those bugs. But it was relative ease. It was just a little bit of a delay. One thing that we have experienced as Dow's digital journey expands beyond the simple not simple applications, but beyond these use cases, our basic AI knowledge across the company is really starting to grow. So we haven't necessarily had to focus so much on, as a project team, on resolving call it the knowledge gap with most users. That has naturally grown within Dow and is making our deployments a little bit easier. Now, the final challenge we've experienced is quantifying the value that this application is providing. It's a sizable investment for Dow, and so obviously we need to be providing a return on that investment. And I'll touch on some of the positive outcomes that we've had in a moment, but we're finding it very difficult in these early stages to quantify that value. So that's because in this case, we've got external factors that have a big impact on these facilities. So things like market conditions, unplanned events in downstream facilities, unplanned events even in other areas of the same facility. And it's very difficult to filter those out of the metrics that we are tracking. We're also applying this technology to assets that have been highly optimized over decades of operation. So finding 1% is very difficult. We remain committed to that because that 1% does hold a lot of value for Dow at this scale. But again, we're trying to move a big machine here. And then finally, unplanned event avoidance can be tough to quantify at the best of times. I like to draw parallels to my time in health and safety. Companies like Dow spend millions of dollars every year, whether it's indirect or direct, on EH&S related initiatives to ensure that people aren't injured while at work. And while we're starting to see some metrics, or not starting, we're seeing metrics like injury rates falling over time, it's very tough at times to attribute spending directly to those injury rates falling because there's always an unquantifiable element of luck when it comes to EH&S. And so we still spend that money though, right? It's the right thing to do to protect people while they're at work, but we are seeing change over the long term. And so the money is obviously doing something. And I do believe it's drawing parallels to this. It's the same thing. We know the positive benefit or the potential for a positive benefit is there. We just need to stick with it and continue down this path. And I am confident that it is going to come. Okay, with that, I also want to make it clear that our work hasn't been in vain. We are starting to see some positive outcomes, even though it's still relatively early in terms of our deployment schedule. And I'd love to be up here saying that we've avoided a large number of unplanned events and saved Dow millions of dollars. I'm sure C3 would also like me to be up here saying that. But we haven't yet had that multi-million-dollar unplanned event avoidance that we can attribute directly to this application. But it has provided a lot of valuable information to end users, whether it's new information or alerts. One key shift that I've kind of felt for myself or have observed for myself is a shift towards proactive event avoidance instead of reactive event avoidance. For my time in operating facilities, there was always something going wrong that we needed to investigate and learn from and improve. And while I don't think that need is going away, what I'm finding or seeing with the AI revolution is that it's making better use of that little time that we have to focus on those types of proactive activities. We can make more valuable use of our time and try and be more proactive in a shorter period of time and with less effort. So a good example, we had a recently planned outage where we were taking a furnace down for maintenance. And as you take a furnace down, you may put certain instruments in manual or put them at a manually set value to avoid nuisance alarms or to prevent or to conduct maintenance on those particular instruments. And so in this case, when we brought the plant back up, we found the application alerted us to one vibration probe on a piece of equipment was left at a manually set value, and our process control system didn't pick that up. And so with that, we were able to go put that instrument back in monitoring the operating data, and at the same time, we weren't investigating why we didn't get a vibration alarm after an unplanned event. So that's just like a simple example of a proactive approach. We've also had it detect analyzers that are providing results that are starting to drift. And so it allows us to perform a calibration before those drifting results result in automated actions that are undesired or alarms to the control room. And so historically, we rely on our production engineers, our technical advisors, and our operators to monitor trends and identify these potential issues. So we're very reliant on their experience so that they know where to look. Now, rather than relying solely on that experience, we have this application that is monitoring and pointing them in the right direction much more quickly, I would say. It also helps new individuals or less experienced individuals become effective much more quickly. So we have another case where this application has detected temperature deviations in some heat exchangers, and it's due to fouling within the exchangers. And so the current temperatures are not a concern. They're well within the normal operating range. And so a technical advisor or an engineer may not necessarily key in on something being amiss here. But what it is happening is it's varying much more quickly from what we would expect to see during a stable operating period. And so with these particular exchangers, once the fouling gets to a certain level, we have to take a furnace outage in order to be able to clean them. And these furnace outages are on a very fixed schedule. And so we would be running rate restricted until we get to that next furnace window. And so this is where the application has allowed us to detect this issue and take action to slow the fouling or in some cases even reverse it. So this is probably our first potential event. It's still under investigation, but this is the first potential event that has that multi-million-dollar impact avoidance that so we're watching it pretty closely, but it's still under investigation and we need to be able to correct that course. And so the current alerting is not perfect. There's still non-value alerts. There's still false alerts, I would say. But every time we have one of those, we're working to learn from them and improve to minimize that impact to the day-to-day of an end user. This is part of the journey, and that's one thing that's sometimes tough to comprehend. We know that these imperfections are going to happen, but we need to learn from them, and perfection is the goal. I don't think, we may never get there, but I do think that we can get a lot closer as the application or the AI itself evolves and our approach and the way we use it modifies as well. So where are we going from here with Endow? So with this application in particular, we're accelerating deployment. We've seen enough to know that there's value here. And so we completed 4 facilities in 23 and 24. We're progressing and we're targeting to do 8 this year. And this is going to come with new challenges that we haven't yet experienced. I mentioned all of the deployments so far have been in the US Gulf Coast. We're now going to other geographies. So we're going to be dealing with, logistically in terms of time zones and travel, but also in terms of local perception of AI, language barriers, local cultural dynamics, and that sort of thing. So there's definitely going to be more learnings as we continue to progress. We're also exploring other asset classes like critical rotating equipment and separations processes. This approach can be used in a variety of other use cases as well. We just focused on the furnaces so that because it has the most value for us. We're also exploring other offerings from C3 AI. We recently completed a generative AI and large language model trial within one of our facilities to merge the knowledge we're gaining from this application with the plethora of information that we have on those assets. So things like maintenance data, operating procedures, what else do I got here? Financial information, global best practices, and more. The overall intent is just to make people's lives easier on day-to-day and more efficient. So we're still analyzing the results of that, but maybe that's what I can talk on next year. Generally speaking, Dow is going to continue to pursue a transformation in other areas outside of our relationship with C3. You probably noticed that some of the images in this presentation were created using Microsoft Copilot. That's just one very simple example of what Dow is exploring in other areas. And I could talk up here all day on the other things that we're exploring, but we'll save that for another day. So before I close, I have the privilege of being up here today and speaking, but I do want to highlight that this is very much a multifunction, multi-company effort. Thanks, some of the Dow folks are at the conference here today, so if you're in the audience, I just want to extend my thank you and appreciation for your efforts on this. Your work has been instrumental to our success. C3, I think we only have one person from C3 here today, but without their support, we definitely wouldn't be where we are today. They're very willing to assist, and they're very flexible, also read as patient with Dow, and so their work is very much appreciated. It's a very collaborative effort that I do think is going to lead to big changes in how we operate our crackers. With that, thank you all for your time today, and I look forward to your questions in the Q&A.